Hello and welcome to SAS Junior Math. Today we are going to be starting with geometry and we are going to be looking at the basic introduction in geometry. So in today's video we are going to be looking at the differences in what I have listed here. Now we're going to be starting with point. What is a point? A point is a location on a plane surface that denotes an exact position. So I can say this is a point. I can say this is a point. It denotes an exact position on a plane surface. What do you mean by the word plane? So plane here means flat surface. A plane surface can also be regarded as what? As a flat surface. And for example now, where I'm standing on the floor is an example of a flat surface. This is an example of a flat surface and of which a point denotes a location or an exact position on a plane surface. Now, a point can be represented with a letter. So I can say this is point A, this is point B, this is point C, and so on and so forth. Now let's move on to the next one. The next one is line. A line can be seen or can be regarded as a combination of more than one point. So if we have continuous points, then we can see that as in the combination of such points can form a line. For example now, let's look at this. Now let's look at this. One thing we should know about a line is this. A line extends continuously on both sides, as in on both ends. So for example now, this goes on and on infinitely for life. And on this on our right hand side, it goes on and on for life. So the points here are infinite. So that is why we call this what? A line. And a line, and this is how we represent a line. I can say this is line AB. You can see the arrow on it. I can say this is line BC, line CD, line DE. I can as well say this is line DC, and I can as well say this is line BA, and so on and so forth. So this arrow here tells us that it goes infinitely in both directions and so on forever. So that is what a line, that is line. So the difference between a point and a line is that a point just it represents an exact position, but a line is as a result of the combination of what? Of more than one point, and it is infinitely in both directions, and it can be denoted with these arrows on both sides. Now let's look at the third one, which is a line segment. A line segment can be measured. A line segment is finite, and if I want to look at a line segment, I will call this is a line segment. Why? Because it has a beginning and it has an end. So in this case, unlike a line that is infinitely that is infinite on both sides, for line segment it has a direct measurement in the sense that it has a beginning and it has an end. So it is finite. It can be measured. It is as it is like that. So now the difference between a line segment and a line is that for line segment it has a beginning and it has an end. But for line it does not have an end. It goes on infinitely, and we can measure a line segment as it can be denoted in this form. So or BA. So I can call this line AB. This is segment AB and this is BA. And if you look at the line up here, you can see that there is no arrow, which denotes that what? That it has a beginning and it has an end. So that's the difference between a line and a line segment. So let's look at number 4. Number 4 is rays. So what do you understand by the word rays here? The rays combines the features of both lines and line segment. Why? Because for rays, a ray has an endpoint and it goes infinitely in one direction. In the sense that this endpoint, I can call this endpoint A, and it goes in on and on like that in one direction. And I can as well give it a name. Like for example, if I want to represent rays, so I can say this is AB, and I will give you this. It can be denoted with this. This denotation, this symbol here tells us that it's starting with from an endpoint and it goes on infinitely. So let's assume we have point A, B, C. So I can say this is AB, and I can as well say that it is AB, and I can as well say this is AC. But I cannot call this BC. Why? Because the endpoint is A and not B. So we'll move on to the next one, which is horizontal line. So what are horizontal lines? Horizontal lines are lines that runs from left to right. They are lines that runs from left to right. So for example now, if you sleep in the house, the sleeping posture can be seen as an example of an horizontal position. So an horizontal position, lines runs through from left to right. So I can say this is an horizontal line. This is an horizontal line. Then a vertical line runs from up to down, from up to down, or you can say from north to south. This can be from west to east, that is for horizontal line, from west to east. For vertical lines, we can say it runs from north to south. So as I am now, let's assume I'm a line. What are you going to call me? I'm automatically a vertical line because I run from the north to the south. So that is the difference here. So if I stand vertically, and when you sleep horizontally. So I want you to just picture a vertical position as my standing position and horizontal position as a sleeping position. So with that, I don't think you forget in a hurry. So let's look at the seventh one, which is intersecting lines. Intersecting lines. So intersecting lines has to do with two lines meeting at a point. Intersecting lines has to do with two lines meeting at a point. So if I say this is A, B, C, and D, and they meet at point X. So we can say this is what? This is intersecting lines. However, for an intersecting lines, it doesn't really have to be 90 degrees. It can be any angle. It can also be in this form. So far they meet at a point. At the point of intersection, we can also call this what? An intersecting line. So from there we'll move on to perpendicular line. Perpendicular line. So perpendicular line is also a form of intersecting lines, but in this case, a perpendicular line forms what is called a right angle. That is, it forms a kind of shape, L. So in this case, this perpendicular line is a special type of intersecting lines, unlike unlike in number 7 here, when we are treating intersecting lines. In this case, the form at which the lines may bend doesn't really matter. What matters here is so far they intersect at a certain point or at a common point. But for perpendicular lines, it has to be in the form of letter L, and it has to meet in such a way that both sides are straight. That is, it's not that it is bent in this way or so on like that. And if you look at it, it has to be what? 90 degrees. So I can also say that a perpendicular line is also 1/4 of a revolution. Revolution is 360 degrees. So if I can say this is 90 degrees, this one too 90 degrees, 90 degrees, 90 degrees. If you add them together, it gives us 360 degrees, which is a revolution. So I can say that a perpendicular line is like a quarter of a revolution. So it has to be a straight, it has to be like letter L. That is just it. So let's move on to number 9, parallel lines. Parallel lines are lines that lie on this in the same plane surface, or they lie on the same plane surface, and they have equal distance apart. One thing about parallel lines is that they never meet. They never meet. They can always go on like that without touching themselves. That is parallel lines. Then we also have transversal line. A transversal line, in fact, number 10 is going to be from number 9. A transversal line is that line that cuts, so automatically I'm changing this to number 10 because I'm talking on transversal lines now. A transversal line is that line that cuts a pair or more than a pair or more parallel lines. So as you can see, we have three parallel lines. We have three lines that are parallel to themselves. So the line that cuts the set of parallel lines here can be regarded as what? A transversal line. It can also be regarded as transversal line. And we have the last one, which is oblique. Oblique lines are neither they are neither horizontal nor vertical, but they are slanted somehow like this. I can call this an oblique line. I can also call this an oblique line. Can you see? They are neither horizontal nor vertical. They are neither horizontal nor vertical, but instead they are slanted in this manner. So we can see this is an example of what? An oblique line. I hope you enjoyed the video, and I'll see you soon in my next video. Thank you.